I'm going to turn it over to Aaron Wintersmith with Capital Engineering. He's going to talk about some steps we can take to save energy in heating and cooling.
Thanks, Chad. So as Chad mentioned, the mechanical systems for these buildings were typically steam-based. And in addition to their age, this system suffers from a low inherent fuel efficiency, pretty high cost of ownership, arguably with a specialized maintenance budget, and importantly for advancing to net zero, they really have limited opportunity to use on-site or renewable fuels because they have a very high design temperature, right? We're talking 210 to 250 degrees. They're a barrier towards advancing to net zero. As Chad also mentioned, these systems typically don't feature a cooling system, and while that was typical when they were built, today's users really expect cooling in the classroom, and it's considered really a barrier to the learning environment when the classroom's not comfortable. So we need to find a way that we can add cooling to these systems without really resulting in as little additional energy use as possible. For the heating system, we see the first step as a replacement with a heating hot water system. This system would use a much more efficient boiler, about 96% efficient on site, and most importantly uses a much lower water temperature. We've paired it here with radiant beams in the ceiling, which leads to a water temperature of about 130 degrees. This allows a much easier deployment of solar panels on the roof that would convert the sun's heat directly into hot water, not in electricity. This is much more efficient, and we've targeted a 50% reduction in heating use due to that. The step moving forward from here to advance to net zero is to target the boiler and convert it to a heat pump design. This design uses electricity instead of gas fuel, removing the carbon pollution from the site, and it increases the utilization of the PVs. It uses an on-site renewable source. It's also even more efficient than the condensing boiler was. For cooling, we can use those same radiant systems that we had proposed for heating, and again, we're using a more moderately temperature water. We've targeted about 65 to 68 degrees, which allows the use of new and different cooling strategies for this classroom. Here we've shown a classic design that uses a chiller and a tower. At Santa Barbara and other mild climates, we actually think that you could eliminate the chiller entirely, or perhaps use new technology, air source chillers. Historically, these were not very efficient. We're seeing a lot of new technology in that area, coupled with this warm water temperature and the Santa Barbara climate. We might see those in a range of 18 to 20 EER, whereas today typical equipment is in the 11 to 12 range. So the variable sources allowed by the system allow a low energy